Good afternoon, everyone. Welcome to this webinar. My name is Grace Cho. I am the marketing manager here at RFHIC. And today I will be discussing a novel method for carbon negative hydrogen production utilizing microwave generated technology. So this webinar will kind of give you a top level approach to how high powered microwave generator is being used for next generation hydrogen production, as well as other bycarbon products as well. So before I get started, let me share our presentation with you. All right. So for today's agenda, I will kind of give a general overview about RFHIC and our technical capabilities, and then give you kind of a brief overview about RFHIC's GaN solid-state microwave generator products. And then later on, I'll dive into a brief technical overview about plasma in itself, and the concepts behind and the methodologies behind plasma conversion technology, and kind of highlight some of the benefits that come with utilizing this technology. And then later on, I'll just kind of wrap up the presentation with some case studies and show you some of our accreditations and patents. So RFHIC is a global leader in designing and manufacturing gallium nitride-based RF and microwave components for various different types of sectors, including telecommunications, radar, as well as RF energy, which is commonly known as industrial, scientific, and medical applications. So we are fairly well known within the telecommunications and radar sector, but we've also delved into the RF energy sector probably around 8 years ago, utilizing this microwave generator technology for microwave heating and plasma generation applications. So as you can see, RFHIC, we provide this one-stop GaN solution to all of our customers, allowing us to provide from small power devices all the way up to high-powered microwave generator systems, all within our in-house production facility. So, we're capable of designing and manufacturing these components all the way up to high-powered microwave generator systems that are operable up to 1 megawatts of power. So like I mentioned earlier, we roughly started this RF energy side of the business around 8 years ago, with kind of the idea and concept of, utilizing solid state methodology for microwave energy. So we're utilizing a solid state approach to creating microwave energy for various types of industrial and scientific and medical applications, versus some of the conventional ways that are currently being used. A lot of vacuum tube-based systems are currently being used in this industry, but we definitely do see this transition towards solid-state technology. So here I'll just kind of give a little bit of a highlight in towards the reason behind this transition towards GaN solid-state from conventional tube-based systems, is the fact that there are a number of numerous advantages that come about utilizing GaN solid-state for microwave heating and plasma generation applications. So as you can see here, in terms of power levels, it's much scalable. So in terms of configurations of microwave generators compared to conventional magnetrons or compared to conventional tube-based systems, solid-state technology is combinable, meaning that you're able to combine multiple microwave generators in order to scale the power levels that are required by your end customer. So maybe in the beginning, if you were to start out with smaller yields and you would like to increase the powers, that's capable with our systems. Secondly, a big advantage is the ability to control the system features and electrical specifications on a digital scale or a digital manner. So things like, operating the frequency, the power levels, the phase, and then really kind of manipulating and controlling the system via a digitized network is very important, especially in today's shift towards digitization, and being able to process that in a digital manner, unlike conventional tube-based systems that are very much analog-based. And lastly, I think a huge advantage of why a lot of customers are transitioning over to GaN solid-state technology is the fact that it has much greater lifetime than tube-based systems do. On average, I think for us, our GaN solid-state microwave generators have an average lifetime roughly between 50,000 to 100,000 hours. But it does vary depending on usage. But again, far much longer lifetimes than conventional tube-based systems provide, meaning the fact that it's much lower in terms of OPEX costs, less maintenance for the end customer, and a lot of redundancy is involved in order to provide you the most efficient and reliable source of microwave energy power. So for us, it's not just this product in itself, but we do manufacture and design various different types of microwave generator products, ranging from 1 kilowatt all the way up to multi-megawatts or multi-kilowatts. But specifically catered for hydrogen production, we wanted to focus our product portfolio on this 30 kilowatt microwave generator system. This generator system operates at 900 to 930 megahertz. And it is a turnkey microwave generator solution that's equipped with our state-of-the-art GaN solid-state power amplifiers, has a waveguide combiner embedded, control module, as well as a power supply unit. So it's essentially a very turnkey system that allows you to plug and implement into your current system in an easy and simple way. So this system in itself has a scalable architecture, meaning that it allows you to really increase the power levels as you see fit, utilizing a combining methodology. So to kind of visually show you that, we've kind of proposal here in terms of what the scalable architecture would look like in terms of scaling out the 30 kilowatt system in order to generate 1 megawatt of power. So, with that being said, we definitely saw a huge potential for our GaN solid-state microwave generators being used for what we call within this industry is power to X applications. There's just a variety of applications that plasma technology or microwave generator technology can be used for. And so, by utilizing plasma, we can convert these natural gases into hydrogen and other high value chemicals, for example, such as acetylene, graphene, and ammonia, I believe, without producing any CO2. And that's kind of the advantage to this methodology is the fact that it produces no carbon emissions and other forms of greenhouse gases, especially if you look at it and power the microwave source with renewable energy sources. So, for those kind of that are not familiar with plasma, I'll just kind of give you a little bit of a overview. So plasma is often called the fourth state of matter. So it's essentially a superheated matter that's kind of so hot that, you know, the electrons that are within are ripped away from the atoms that are kind of formed in ionized gas. So this energized gas is, you know, is like a state of matter that's going to be used as a tool to convert natural gas, you know, such as methane, into hydrogen and other types of bicarbon products. And it's, you know, not using any air or oxygen within the process. So essentially, it's eliminating any oxidation from taking place within the reaction, thus, you know, producing no carbon emissions and greenhouse gases. So, I mean, the key advantage to this methodology is again, like I said, it's producing no carbon emissions. So it's a much more greener methodology comparative to conventional methods that are currently being used within the industry today. The process requires far less energy consumption compared to, you know, other competing technologies that I'll kind of mention later throughout the slides. And lastly, I would say the process is very much economically advantageous to other methods, is the fact that plasma conversion technology not only produces hydrogen, but it also does produce other, you know, high value hydrocarbon products, you know, such as, you know, acetylene, graphene, ammonia, and much more. And so those can be actually, you know, high value products that can be used later on for profitability. And I guess lastly, in terms of the key advantages for plasma conversion technology is the fact that this methodology provides a much more highly efficient and stable source of plasma, unlike conventional technologies do. And so this is offering a much more efficient source, allowing it to offer customers more scalability, reliability for commercial scale. So this is just kind of a general overview or a comparison, I would say, to conventional methodologies. Like I mentioned before, I think currently the world's, all of the world's, right, I believe 95% of the world's hydrogen production is done via SMR, which is a steam methane reforming method. And I believe a lot of people within this industry know that steam methane reforming is a very capital intensive process that emits a lot of CO2 and, you know, other forms of greenhouse gases into the atmosphere. And so compared to steam methane reforming, we definitely see that, you know, utilizing microwave plasma technology or microwave conversion technology, it's much more cost efficient for the end customer, and it's a much more greener process, especially again if you're utilizing renewable energy sources to power the microwave generator, then it's essentially zero carbon emissions into the atmosphere. But here, just kind of going into a little bit more detail, we're kind of illustrating the plasma conversion process. So here you can see that's starting with natural gases, you know, such as methane, from being implemented into the reaction chamber. And then from here, by utilizing microwave generated plasma, what it will essentially do is it will disassociate the chemical bonds that are in methane in order to produce, you know, separate and purify into hydrogen and, you know, other valuable high carbon chemicals. And so, you know, this can be definitely used and applied to a wide variety of downstream applications. And I mentioned a couple here on this slide. So you can see, you know, battery powered conductive polymers. I know acetylene is a very important hydrocarbon chemical that gets used heavily within the welding industry. and also various different types of polymers and composites also utilize a lot of these high value hydrocarbons and hydrogen chemicals as well. So, lots of applications and lots of downstream applications of utilizing these technologies for various different applications. Here are just a last couple of pictures of our GaN solid-state microwave generators being utilized for microwave plasma CVD applications. CVD is a chemical vapor deposition equipment that gets used to manufacture synthetic diamonds, as well as within the semiconductor industry. And then on the right side kind of depicts our microwave generator systems being used for plasma torch applications, which then can be used for applications such as hydrogen production, as well as waste gasification. And these are some of our patents and accreditations in terms of our systems, as well as just our overall company. So, in summary, hopefully we've been able to kind of bring about more awareness to the utilization of microwave plasma technology for carbon negative hydrogen production. I definitely believe that this technology and method is kind of breaking down a lot of traditional boundaries within this industry. But we definitely do hope that we see this method being used for next generation hydrogen production. So, one thing that I would like to state before I wrap this webinar up is that we are definitely looking for collaborative opportunities with companies within the hydrogen sector. As mentioned before, we are experts in RF and microwaves. So in order to really commercialize this method and this technology, we definitely do require a diverse range of expertise from various different backgrounds, especially within the hydrogen sector. So if you are interested in learning more about our products or any of opportunities for partnerships, please do contact me directly. I've put in my contact information on the end of the slide. But lastly, and if you have any other questions and would like to learn a little bit more about RFHIC, as well as our products, please feel free to visit us at our website at www.rfhic.com. So I guess that's the end of our presentation. And again, thank you so much for tuning in today. Hope you guys have a great day.